because you get more snowfall, because the atmosphere holds more water vapor. And of course that's true, but the common sense conclusion would be as the planet gets warmer, the ice gets smaller. And now we have a way to test that, because we have this spectacular satellite which measures GRACE, which measures the gravitational field, with such a high precision that we can measure the mass of the Greenland ice sheet and the Antarctic ice sheet. And we see that during the winter, it gains mass, and then during the melting season, it loses mass. But overall, it's losing mass at a rate of now almost 200 cubic kilometers per year. And that rate, we only have these measurements for a few years, but we have other ways to estimate. And it looks like if we go back about 15 years, that it was close to mass balance. And that rate of ice mass loss has been increasing over the last 15 years. So if we want sea level to be stable, it's clear that 385 ppm is too much. And probably, based on prior interglacial periods, if we want the ice sheets to be similar in size to what they are, we probably shouldn't have CO2 much more than 300 ppm. Now another effect which is observed is the impact of global warming on the overturning circulation. The rising motions in the tropics and the subsidence in the subtropics, which causes the subtropics to be dry, that circulation cell is expected to expand as the planet gets warmer. And we observe empirically that there has been an expansion on the average by about 4 degrees of latitude. And that's beginning to affect the southern United States and the Mediterranean region and Australia and parts of Africa. And so, for example, Lake Mead and Lake Powell are only about half full, and that's probably, at least in part, due to this general climate trend. And a related effect is the increase in fires that is occurring not only in the western U.S., but in Canada and Siberia. An important effect is the melting of glaciers, which is occurring worldwide. This is a picture taken in the Himalayas, and then a more recent picture where that glacier is now gone. The glaciers in the Himalayas and the Rocky Mountains and the Andes Mountains provide fresh water in the summer and fall for hundreds of millions of people. In the spring, you get snowmelt, which gives you a huge flush of fresh water. But as the summer and fall go on, there's no more snow, but there's still glaciers melting and providing fresh water. But once those glaciers are gone, then there's these rivers will be running much drier, and that's an important climate impact. In fact, these glaciers have now lost. The black part of these bars show the mass loss of the glaciers as a function of altitude of the glaciers. So already a significant fraction has been lost, and there's a danger that it could all be gone within 50 years if we stay on business as usual. Coral reefs are another practical impact of, well, there's several stresses on coral reefs, but two important ones are the acidification of the ocean. As the atmosphere has more CO2, and the ocean takes up the CO2, the ocean becomes more acid. And that is destructive for shelled animals that are made carbonate or with carbonate skeletons, because in effect it dissolves the shell. And also the increase in temperature is a stress on coral reefs. So all of these things tell us that we would be better off if we aimed for having CO2 of less than 350 parts per million. Now, if we want to keep a planet similar to that which has existed for the last 10,000 years. Unfortunately, CO2 is already 385 parts per million. And when we put a pulse of CO2 into the atmosphere by burning fossil fuels, part of it disappears quite rapidly. After only 20 or 25 years, about half of it is gone. But then the rate of loss slows down, and after 1,000 years, about 1/5 of it is still in the atmosphere. The reason is that as the ocean takes up CO2, it then begins to resist taking up any more because the CO2 in the ocean can come back out. And until the CO2 in the ocean has been taken up and has been deposited as sediments on the ocean floor, it will continue to resist taking up the remaining fraction. And that takes thousands of years to form those sediments. So you simply cannot, the bottom line is this: we cannot burn all of the fossil fuels without producing a doubling or tripling or quadrupling of the amount of CO2 in the atmosphere. What we've burned so far is the purple part of oil, gas, and coal. We've probably used about half of the oil. There are different estimates for how much undiscovered oil there is. But most experts think we're close to peak oil, which means we've used about half of the oil. You can't practically capture the CO2 from oil because that's used in vehicles. You can't capture the stuff coming out of the tailpipe. But you could decide, so the target, if we want to preserve a planet that looks like the one we have, then we're going to have to target coal because that's the biggest source, and we could decide we'll only use coal at power plants which capture the CO2, none of which the present power plants do. If we did that, if we said we'll have a moratorium on coal-fired power plants and we'll phase out the existing ones by 2030, then CO2 would peak at a value of something between 400 or 425 ppm, depending upon which estimate is more accurate for the reserves of oil and gas. And then, although that would still keep CO2 above the 350 parts per million for a couple of centuries, we could draw it down faster by means of improved forestry and agricultural practices, or if we would capture CO2 at the gas-fired power plants, but especially the reforestation in areas that on marginal land that has been deforested. So it's technically feasible to get back to 350, but it would require a quick coal phase-out over the next 2 decades. And many people don't realize that coal is the main source of the excess CO2 in the atmosphere, as much as oil and gas put together. And on the long run, it's potentially even a larger fraction just because the reserves are the largest. So that's really what has to be addressed. Now, China has passed us in the past year. They now emit more CO2 than the United States. But as far as who is responsible for the climate change, it's actually mainly the United States because of the very long lifetime of the atmospheric CO2. So we're more than 3 times more responsible than any other single country. The energy departments and fossil fuel companies say that it's a God-given fact that we're going to use all the fossil fuels. Well, I think that we should dispute that, and I think especially young people should dispute it.